Hello students, welcome back to the channel. If mathematics feels difficult, don't worry. Today we will understand irrational numbers so deeply that you will never forget them. Take your book and let's begin. Can you tell me the exact length of this diagonal? You may say that 1.41. But wait, is it exactly 1.41 or is it 1.414 or is it 1.4142135? What if I tell you that this number never ends and never repeats? And even more surprising, no fraction in the world can exactly represent it. Today we are going to solve one of the mathematics' greatest mysteries, that is, why is root 2 irrational? By the end of this video, you will prove root 2, root 3, root 5, 3 root 2, 5 minus root 3 are irrational. And board exam questions, real life applications, common mistakes you make, and exam tips. Can these numbers be written as fractions? We can write 2 as 2 upon 1, 0.75 as 75 upon 100, which is equal to 3 upon 4, and minus 5 we can write it as minus 5 upon 1. So these are rational numbers because we are able to represent in the form of fraction. But look at root 2. Root 2 is equal to 1.41421356. It never terminates, it never repeats. Therefore, we can define irrational numbers as a number that cannot be expressed as p by q, where q is not equal to 0 is called an irrational number. So we can say that non-repeating and non-terminating numbers are irrational numbers. For example, root 2. Root 2 is an irrational number, root 3, root 5, even pi. Usually for calculation purpose, we represent pi as 22 upon 7, but it is not an exact value, it is an approximate value. When you divide 22 by 7, you will get a non-recurring and non-terminating decimal. So it is an irrational number. Even root 15 is also an irrational number. Now take a calculator and observe here. You are getting the answer 41421356 etc. Can you predict the next digit? No, right? These endless non-repeating nature makes it irrational. Now we'll understand where we use these irrational numbers. See here, there is a square tile of side 1 meter. We know the Pythagoras theorem. According to the Pythagoras theorem, the hypotenuse square is equal to sum of the squares of other two sides. Or we can say it as h square is equal to b square plus p square, that is base square and perpendicular square. Hypotenuse square is equal to base square and perpendicular square. As these two are 1 and 1 meter, so hypotenuse is become 1 square plus 1 square, that is equal to hypotenuse square is 1 plus 1 is 2. So hypotenuse square is 2 means hypotenuse is equal to root 2. So this diagonal become root 2. This value is used in construction, architecture, mobile screen, computer displays, engineering drawings. Even A4 papers are designed based on the ratio 1 is to root 2. So irrational numbers are not imaginary. They are everywhere around us. Let us discuss an important theorem, that is, if p is a prime number and p divides a square, then p is also divides a. We'll understand by taking one example. Suppose a square is equal to 36. Since 3 divides 36, therefore 3 divides 6. This theorem helps us to prove irrationality. It means that any prime number which divides a square numbers also divides its root. You can take one more example. If a square is 64, 2 divides 64, therefore 2 divides even its root. That is 64 root is 8. So even it divides 8. This is an important board exam tip. You need not to write the proof of this theorem unless specifically asked. Let's find whether root 2 is irrational or not. This is the most important proof. You have to solve it step by step. In the first step, assume root 2 is rational number. Therefore, root 2 is equal to a upon b because we can represent in the form of p by q, where a and b are co-prime numbers. Co-prime numbers are two integers that share no common factors other than 1. In the next step, square on both the sides, that is root 2 square is equal to a upon b whole square. Root 2 square here, root 2 and power 2 get cancelled. Therefore, 2 is equal to a square upon b square. Now, here a square is equal to 2b square. Thus, a square is divisible by 2. Hence, a is divisible by 2. Therefore, a is equal to 2c. Now, substitute 2c in the place of a here. In equation 1, that is 2c whole square is equal to 2b square. Now 2c whole square is 2 square is 4 and c square which is equal to 2b square. Now b square is equal to 2c square, right? Therefore, b is also divisible by 2. If both a and b are divisible by 2, then they are not co-prime number. Contradiction, right? Therefore, our assumption is wrong, hence root 2 is irrational. Let's imagine two friends A and B. They promised we have no common friends. Suddenly we discover both are friends with 2. That means they lied, right? This contradiction proves our assumption wrong. This method is called proof by contradiction. So proof by contradiction works here. Similar to root 2, we'll solve for root 3. In the first step, let us assume root 3 is rational. Then root 3 is equal to a upon b, where a and b are co-prime. Now square on both sides. That is root 3 whole square is equal to a upon b whole square. So here root and power 2 get cancelled. Therefore 3 is equal to a square divided by b square, which implies a square is equal to, bring b square here, which become 3b square, or 3b square is equal to a square. Therefore, a divisible by 3. Let us take a is equal to 3c. Then substitute this in equation 1. That is, instead of a, we have to write 3c. That is, 3c is equal to 3b square. 3c whole square is equal to 9c square, right? 9c square is equal to 3b square. Now, b square is equal to, here 3 one time, 3 3 time, right? So b square is equal to 3c square. Thus b is divisible by 3. Again, both are having common factor 3. It is a contradiction, right? Therefore, root 3 is irrational. There is an important result that if root 2 is irrational, then 3 root 2, 5 minus root 3, 3 plus 2 root 5, these are irrational because when you add a rational number with irrational number, you will get irrational number, or when you subtract a rational number with irrational number, you will get irrational number. And when you multiply a rational with irrational, this is rational and this is irrational. When you multiply those two, you will get irrational. When you add, subtract, or multiply a rational number with irrational number, you will get irrational number only. Let us discuss some common mistakes you make in exam. The first one is writing root 2 is equal to 1.414, which is wrong. This is only an approximation. It is not an exact value. Root 2 is having non-terminating and non-recurring decimals. And the second mistake is forgetting A and B are co-prime. It's very important step. You must always remember that A and B are co-prime numbers. These two are not having any same factors. Or you can remember like both are not having any common friends. And the third mistake is not writing contradiction. Always conclude your answer with the statement, this contradicts the fact that A and B are co-prime. And the last mistake is missing the final statement. Always write hence root 2 is irrational, or root 3 is irrational, or 5 minus root 3 is irrational. Now let us solve some exercise problem. The first one is prove that root 5 is irrational. Here the first step is assume root 5 is rational. Therefore root 5 is equal to A upon B, where A and B are co-prime. And in the next step, square on both sides. That is root 5 whole square is equal to A upon B whole square. Now here square and square root get cancelled. Therefore 5 is equal to A square upon B square. Now we want A square. So A square is equal to shift B square here. It becomes 5B square. Consider this as equation 1. Therefore, A is divisible by 5, which is a factor of A. Let us take A as 5C. Now substitute this in equation 1. In the place of A, substitute 5C. Therefore, 5C square is equal to 5B square. 5 square is 25. 25C square is equal to 5B square. Now you can cancel it. 5 one time. 5 times, which is equal to 5C square is equal to B square. See here, B is divisible by 5. Here both are having common factor, which is contradiction. Therefore, root 5 is irrational. It is simple to solve, right? The same steps you are following here. And the next question is prove that 3 plus 2 root 5 is irrational. So in the first step, assume the opposite, that is, assume 3 plus 2 root 5 is rational. That means 3 plus 2 root 5 is equal to R, where R is rational number. To prove a number is irrational, we first assume it as rational. If this assumption leads to a contradiction, our assumption is wrong. Now subtract this equation by 3. Subtract by 3. So here if you subtract by 3, the remaining is 2 root 5, which is equal to R minus 3. Since both R and 3 are rational, R minus 3 is rational. The difference of two rational numbers is always rational. Now divide both sides by 2 to remove this 2, which become 5 is equal to R minus 3 divided by 2. Since R minus 3 is rational and 2 is also rational, R minus 3 by 2 is rational. Hence, root 5 must be rational. But we know that root 5 is irrational. This contradicts our assumption. Therefore, assumption is false. Hence, 3 plus 2 root 5 is irrational. First, we assume that 3 plus root 5 is rational. Then, we subtracted both the side from 3 to remove this 3 from the equation gives 2 root 5, which is also rational because the difference of two numbers is rational. Dividing it by 2 on both the side gives root 5, which becomes rational. But we know that root 5 is irrational. This contradiction proves our assumption is false. Therefore, 3 plus 2 root 5 is irrational. Question number 3 is prove that the following are irrational. First, assume that 1 upon root 2 is rational. To prove a number is irrational, we first assume it is rational, which is 1 upon root 2 is equal to R, where R is a rational number. Now take reciprocal of both sides. So when you take reciprocal of this, it becomes root 2 is equal to 1 upon R. Since R is rational, 1 upon R is also rational because the denominator is not equal to 0. 1 upon R is rational. Hence root 2 is rational. If 1 upon R is rational, obviously root 2 should be rational. The reciprocal of non-zero rational number is always rational. Therefore, 1 upon R is rational. But we know that root 2 is irrational, this contradicts our assumption. Therefore, our assumption is false. Hence, 1 upon root 2 is irrational. Here first we assume 1 upon root 2 is rational, then 1 upon root 2 is equal to r, where r is rational. Taking the reciprocal gives root 2 is equal to 1 upon r. Since the reciprocal of non-zero rational number is rational, root 2 become rational. But we know that root 2 is irrational. This contradiction proves that our assumption is false. Therefore, 1 upon root 2 is irrational. Prove that 7 root 5 is rational. First, let us assume 7 root 5 is rational. Therefore, 7 root 5 is equal to r, where r is rational number. To remove this 7, divide 7 both sides. That is root 5 is equal to r upon 7. R upon 7 is also rational because which is in the form of p by q, where the denominator is not equal to 0. If r upon 7 is rational, then root 5 is rational. But we know that root 5 is irrational. This contradicts our assumption. Therefore, our assumption is false. Hence, 7 root 5 is irrational. In the same way, let us solve question number 3, that is, prove that 6 plus root 2 is irrational. What we are doing in the first step? First, we are assuming that 6 plus root 2 is rational. Assume 6 plus root 2 is rational. Therefore, 6 plus root 2 is equal to r, where r is rational. Now, first to remove 6, subtract 6 both sides. Then if you subtract 6 with 6, you will get 0. Therefore, root 2 is equal to r minus 6. Since r and 6 both are rational, r minus 6 is also rational. So, root 2 is rational. If r minus 6 is rational, then root 2 is rational. But we know that root 2 is irrational. This contradicts our assumption. Hence, 6 plus root 2 is irrational. So, whichever the number they may give, first take it as rational, then prove that it contradicts our assumption, then you can easily say that it is irrational. These are the common type of question they'll ask in your board exam. Mainly they'll ask prove that root 2 is irrational, such kind of questions. These are the very important board exam questions. Mainly they'll ask prove that root 2 is irrational. So whenever they give such questions, first you always take the given number as rational, then you prove for contradiction. Now a quick activity for you. Pause the video and find whether root 49, square root 18, 2 plus root 5, 7 plus root 3 are rational or irrational. Got the answer? Root 49 is 7. 7 times is 49. So it is rational. Root 18 is irrational because 18 is not a perfect square. Then 2 plus root 2 is irrational. If you add irrational with irrational, which is equal to irrational, then 7 root 3 is irrational. When you multiply a rational with irrational, you will get irrational. If they're asking for proof, you have to solve these problems as the problems we solved before. Now, some important exam tips are learn the proof stepwise, and even while you are writing the proof, you have to write stepwise. Then write assumptions clearly. Mention the coprime numbers. Whichever you are taking coprime, mention it clearly. Use the theorem properly. Use the theorem if p is a prime number and p divides a square, then p is also divides a. That theorem properly. Then write the contradiction. Write the contradiction means both a and b are divisible by the same number, but they are co-prime number, and which is a contradiction, like that. Then write the final conclusion as therefore our assumption is wrong. For example, root 2 is irrational or root 5 is irrational. You have to write the final conclusion properly. These are the practice questions for you of this complete chapter. You can pause the video and solve all the questions. Let's have a quick summary. Today we learned irrational numbers and the theorem. If p is a prime number and p divides a square, then p also divides a. Then proof of root 2 irrational, proof of root 3 irrational. We solve few exercise problems also. And always remember, rational plus irrational is always irrational. If you are multiplying rational with irrational, you will get irrational. Then we solve some board exams questions and exam tips. If mathematics is the language of universe, irrational numbers are its mystery. And today you solved that mystery. If this video helped you, like, share and subscribe. Comment below. Can you prove root 5 is irrational on your own? See you in the next mathematics class.